Hi everyone, welcome to the Builder Track. I am Muskan Mangla. I volunteer in the OWASP community. I'll be moderating this session. During the next 45 minutes, you'll be listening to Jeroen and Ben present OWASP Wrong Secrets. We have a secret for everyone. Please submit any questions you have during the session in the QA tab, just to the right of this video in the Huawei platform. I'll be asking the speakers your questions in the last 10 minutes of the session. Please note that the chat function is disabled for the attendees, but you can leave comments and chat using the chat tab in the Huawei. I'll introduce the speakers briefly. Jeroen is a typical security jack of all trades as a hands-on security architect with a knack for automation and risk management. Jeroen has been involved in the various OWASP projects, now focusing on OWASP Wrong Secrets. Ben is a freelance security consultant and engineer. Ben's specialties are architecting and implementing cloud security and building secure CI/CD environments in agile, DevOps, and SRE cultures. Now handing over to you, Jeroen and Ben. Forgive me if I pronounce your names wrong. So yeah, over to you guys.
You did awesome. Thank you so much for introducing us. Let's start sharing some screens, see if the technology is with us. All right, all right, all right. I think you can see it now. So welcome everybody to OWASP WrongSecrets. We hope to entertain you a little bit with our project in the upcoming 45 to 60 minutes. And with this consent, I think we can be very short about our introduction for ourselves. So I'm Jeroen, and here right next to me is
Ben.
So we're both project leads on this project. And let's move ahead so we have more time for awesome content. So let's start with a little poll. At this side of the screen, at least for me, I hope it's also for you on the right hand side of the screen, there is this beautiful poll where you can fill in where did you find secrets within the project you had access to. And well, I can't access it on my computer and show it live because then we'll get the funny audio loop back. But right now, I'll refresh it again. I see about 34 answers right over here. Let's see if I can show it like that. Okay, this is a bit funny. I don't think that works very well. But basically, what we can tell is that a lot of people found secrets in Git. A lot of people found secrets in NVARs, in secret managers, in cloud vendor solutions, but also in the CI/CD pipeline. And a few of them found them in Docker containers, in libraries, executables, or in workload schedulers. All right, awesome. With that information, I think we all touched stuff a little bit. Let's get ready to do stuff. So the first question, of course, would then be, if we go to this poll, is, hey, but what are secrets? What can be a secret? So here's a few examples of possible secrets, right? There can be plenty, of course. You can think of various things like your password, which makes total sense, private keys, whether for TLS configuration or GPG, IAM access keys for your cloud vendor, but then, of course, also API keys, or a little bit less easy, OTP seeds, MFA backup codes, 2FA codes for as long as they're valid, QR codes to sign on easily and stuff like that. And all of a sudden, that it starts to grow and grow and grow. So apparently there's quite a few secrets out there. So then the next question would, of course, be, if you had to rotate all your organization's secrets, would you actually know where they are? And not just what, what your team lead decided that it should be, or where your CISO decided it should be, or your lead architect, or whoever rocks your boat in your organization, but also where everybody else eventually put those secrets, which might be in different places, basically. And do you actually know their purpose? Remember how Jack from the other unit basically just committed this password thing? Do you actually know where this is for? More importantly, can you rotate it timely when you're compromised? So if you know where all your secrets are, can you then rotate it? And do you actually know, well, lots of other things about your secrets, who last touched them, stuff like that. So for this, it's again time for a little poll. Again, at the right hand side of your screen, there's a second poll which asks you, do you know the location of all the secrets in your organization? So this poll has been on for quite a while, and we have quite a few responses from what I can tell as well. Oh, it's still growing. Pretty cool. So let's jump in at 30 responses. 5 people said that they know the location of all the secrets in their organization. I'm very impressed by them because I've never worked in an organization where I knew all the secrets or where all the secrets were located, because there were always too many people trying to be quick in stuff. And Ben will also show what quick means in that sense during our demo, but that's for later. Let's not steal his thunder for now. But 26 respondents thus far has responded no. And I think that's really an honest response, because it's very hard to know where your secrets are. So that's about the location of things in the context of secrets. But apparently there's more to this than just that, right? So can you tell us when your secret was last borrowed by an ex-colleague or an active colleague? You know, because some administrative tasks need to be done, or because he or she or it was sacked, and tried to take a few items home to have different licenses, for instance. We can all say that it never happens, but we all also know that this happens very often. More importantly, can you also tell when the secret was not working anymore? So this we often can tell, because then all of a sudden our service is outage, right? Because then the whole service goes down if it's integrated with some other service for which it needed a secret. That is apparently not that hard. Unfortunately, we're often very much just too late, because the outage started and we eventually find out that it was because the secret was no longer working. And then there's this funny guy from Despicable Me that tries to present something for us as well on the slide. So let's assume we found out where our secrets are, which is great. We start monitoring them. We make an alert when they're grabbed, and then we log an entry that they are grabbed. Now the question is, do you log that correctly? Or do we end up having the data of the given secret right in your audit log or in some other log where too many people have access to? Okay. So apparently secrets management is special. By now, we know that many of the things that we present within the OWASP conferences are considered special, otherwise we'd be talking about it. But secrets management by itself, unfortunately, needs some attention. And that is why we introduced project OWASP WrongSecrets. All right, what is it? Tell me more. Let's go. So it's basically a vulnerable app and a secret detector testbed. You'll see when Dem demonstrates the app in a larger portion how that works, and you can find in our README how the secret detector testbed works. What we basically did is we have a bunch of challenges where you need to find a secret within the code or within some other asset that we created for you, where some people have funny beliefs about that a secret over there is safe. And next to that, the secret detector testbed basically has a few additional secrets inside Git, so you can let your secret detector run through and see if it detects the things that are out there. By that, you know how effective your secrets detector is and whether it's configured correctly. We have a few goals about this. So by now you understand we think secrets management is special. So yeah, we would love to educate people on secret management and its pitfalls. And we would like to help people reflect on the secrets management strategy. So while you're doing these exercises in our vulnerable app, ask yourself, hey, are we doing something similar here? Or are we at risk doing something similar? Or have I seen somebody in my organization doing something similar? Should I improve my strategy? And of course, try to promote secrets management as an important facet of security. All of this could never have happened without the tremendous support of our volunteers. So these are most of them. Some of them they didn't want to be mentioned, but still huge shout out to the anonymous people helping us as well. Special thanks to Nana, Tibor, Josh, Mike, and Jos, who did quite a lot of cool stuff to help us out. And special call out to Dave and Martin as our testers, also helping us out a lot on other things. And of course, Special call out to Madhu Kula, who has done a tremendous job on helping us to promote the project correctly, and Bjorn for being an inspiration with many things he has already done for OWASP for such a long time and helped us along the way with little tidbits. Having that said, and of course, huge shout out to Ben. Hey Ben, finally presenting this together. Apologies, gentlemen, and ladies for taking your time on that one. So, okay, so what did we build with the volunteers? You might wonder by now, right? Let's have a look at our architecture. So the vulnerable application is basically a Spring Boot application that sits in a Docker container. And a Docker container you can run on your on your machine directly, but you can also just visit our website in Heroku, which is wrongsecrets.herokuapp.com, which you can also find in the project README. Or we can load it as a pod and run it in a Kubernetes platform. Right now we have scripts to support Minikube, AWS, which is completely terraformed for you, so you can also tear it down correctly, GCP and Azure, as well as Minikube actually, so you can also just run the Kubernetes exercises and the Vault exercise locally. And in every layer, we basically add more secrets. So if you just run the Docker container locally, you get a bunch of secrets. But if you want to enjoy the full flavor of it, use one of the cloud providers noted in this slide to have fun with it. Having that said, giving us a lot of space for Ben to start showing some awesome demos. Over to you.
Yes,
Ben.
well, thank you. Will do. Let me share my screen as well. There we go. All right. So you can find WrongSecrets on GitHub and, like Jeroen also said, on Heroku, and that's the easiest way to try it out in a well, easily. Please don't run any testing tools directly on Heroku. There's not really any dynamic challenges going on. So using things like OWASP SEP, well, while they may yield you some results, that's not really the goal of our challenge. And also Heroku nodes, free Heroku nodes don't really like it when you do that. So be gentle with it. You can, of course, just walk through all of the challenges that are supported by this environment. Once you go to wrongsecrets.herokuapp.com, you'll be greeted with this screen. It's both available in light and a dark mode. And then there's all the challenges listed below. We currently have 18. There are some more in the works on which I'll share later. But there's, like Jeroen said, challenges at every layer here. And you'll also see that some challenges are disabled. So depending on the environment you're running in, you might need to do something else to get it working, or we require some dependencies, etc. So of course, challenges for specific to a cloud environment don't work on Heroku. So those challenges will be grayed out for you. Now, this is all nicely responsive, or at least it should be. And you can even do some of this on your phone as well, if you so desire, for some hacking on the go. What we also want to do, of course, is not only show you and teach you how things go wrong, but also point you in the direction of how you should do things. So not only have we included some resources on the homepage, but when you actually go to a challenge, you can also look at hints, which will provide you with a step-by-step guidance on how to retrieve the secret. And for some of the challenges, we've actually had remarks, okay, I'm doing this, but why is this a bad thing? So we decided to also include a section on what's wrong in this approach. So speaking of this challenge and what's wrong with a centralized hard-coded password, let's give it a go. So what's happening here? And the description gives us a brief primer. So People write a proof of concept, often start with a hard-coded secret, for instance, a password in code. But you may end up pushing your code to production and forgetting that you had still this hard-coded thing going on. So this is one of those things that would be very easy to detect, of course, if you have access to the source code. And one of the easiest ways that's probably installed on, well, nearly all machines is grep. So what we could do is just grep for password. And now, if we do that on our repository, we'll get a ton of results for different reasons. Hopefully you will have maybe only somewhat less meaningful results on your own projects. Let's see, but let's grep in the repo and see what comes up. So there's a lot of things here, and a lot of them are centered around documentation, of course, but there's also some interesting things that may be what we are looking for. I know out of experience, of course, that it should be this one. So let's go ahead, and I've already completed this challenge in this session, but there we go. We found a centralized hard-coded password. And of course, for an open source application, this is especially bad. Don't do this, don't put your secret in code. It gives the entire world access to it. And it's also quite hard to erase this from internet memory. So everything that is behind this password should be considered compromised the second it lands in GitHub. Right, let's go to a different challenge that is related to Docker in this case. I wanted to say a somewhat more complicated challenge, but I wish. It's maybe even easier to figure out where this secret is. So going here, there's the Docker argument-based password. So, you know, maybe if you use Docker, that you can provide command line arguments to set different things, not necessarily hard coding them in the code, but you supply it a password, for instance, in the command line. And thus, this password is now in your bash history, probably, or you may have passed it in a somewhat more sophisticated way, and it's a bit harder to retrieve. But if you use Docker arguments, there's still ways to retrieve this thing quite easily. And we give a brief primer again on how this is done. So in this case, we can easily spot what's happening by looking at how the layers are constructed. Now, if you put your image on Docker Hub, there's this nice overview of the layers. And of course, there are different tools to dissect this. But in this case, we don't even need to do anything special. We just go to Docker Hub and go to WrongSecrets. There we go. Look at the most recent one. And here we have this interesting command, image layer 14, where there's this arg-based password. Hello, global AppSec. This is just a temporary password. Oopsie daisy. So again, this is public for all the world to see. And you may, for your own environment, think of ways, even if this Docker image is private, that this is probably not a desirable thing to do, right? So let's go. That's it. All right. Now, one of my favorite challenges actually is more related to CI/CD. We've had the Docker container, we've had the code, and another place to store secrets would be your CI platform. But of course, if you have a CI platform that stores secrets, then you also need to consider the access to that secrets. And if you have, for instance, GitHub Actions, then GitHub Actions needs to interact with this secret in some way, maybe to access a cloud environment, for example. And if someone creates a workflow that accidentally spits out the secret in the log, or even this might be a malicious thing going on where it's not some error accidentally logging it. It's pretty easy to exfiltrate these things. So normally you may know that GitHub and other CI systems mask their secrets in the logs. So here we see a sample workflow in GitHub. And what's happening is that there's a bash script that loads in an environment variable where we have a secret. So the challenge 13 key. And it will just echo out the key. And that will be masked. And then even if you encode it with base 64 once, then it will probably still mask this output in the logs. But if you encode it twice or thrice, or you can go several layers deep, depending on what you need, then your mileage may vary, but you will probably end up with the secret. So running this command, first we have the plain output where we just load this thing. And indeed, it seems like it's masked. And now there's the double encoded thing. And there we have a double encoded base64 secret. Now, if we go to our terminal and decode that thing, we end up with this nicely random string, which we can put over here. And there we go. We have successfully exfiltrated a secret from GitHub and solved our challenge. So the final thing that I want to show you is also still somewhat related to code, which is challenge 15. Say you have AWS access keys and you accidentally hard-coded them, but you were smart and removed them again, but only after you had already committed your secrets. So one thing we can do is use Trufflehog to detect secrets that are in the Git history. And for our project, naturally, that yields a lot of results. So I had to get a bit funny with Trufflehog and do specifically a grep for the thing we want. But you could just run Trufflehog 3 on our Git repository and then grep for AWS. And there we go in a second or so. It's probably checking it out right now. Processing the results. There we go. So as you can see, there are some different entries related to secrets. And these secrets, they are then again, like in code, easily exfiltrated. But there's a neat thing about this. So say these keys were not put in there accidentally, but rather on purpose. In the sense that once you use these, you know that someone has been going through your code and checking out whether there are any secrets. So a canary token. I'm not sure if you're familiar with the concept, but what we could do, is check out one of these keys. Let me access key ID and then do this. Don't really care about the region, I think. And then do AWS STS get caller identity profile WrongSecrets. And now in this case, let's see, probably used the wrong one, did I? Configure. I didn't sacrifice and go to the demo gods, sorry. There we go. Yes. So I used my canary token. Whoops. And now I've landed on a tripwire on which, as a hacker, you would probably know by this stage that your activity has now been, is being monitored and is now being alerted on. So as a defender, as a builder, this is a useful thing to do, to just leave canary tokens here and there. If someone is rummaging through your code or whatever, and maybe even your local machine, leave one of these on your local machine as default AWS credentials, that if they are used, you know you are compromised. Now, we also have this stats thing in our WrongSecrets app, and this also shows us a web token that's again a canary token, and it shows us what canary token will be received. And the last entry was just shown. This is probably me then going to a specific URL. So that's a nice way for you to know that there, is an attacker maybe accessing your platform. And if this secret is located close to your other secrets, it's probably high time you start doing some incident response and maybe rotating secrets or closing access to some parts of your system to contain. Okay, that's it for this demo part. Let's progress. Now, we have 18 challenges as of now, and we're also working on more, like I said. So what's on the roadmap? Now, first off, we probably want to improve the development experience a bit. Currently, it's quite cumbersome to add a new challenge and go through the testing loop, go through the verification again. So we want to make this easier for everyone working on our project and implement a nicer development experience, for instance, with live reloading. We also want to do some secrets management, secret hiding in binaries, for example. So hard coding something in code is one thing, but you could also hard code it in a binary. And then what would happen is that it's still often quite easily detectable. And there's various degrees, of course, in which this is easy to detect. You can go from some simple string to something that's obfuscated, etc. So that's another area that we are exploring. One thing to note is that all of these challenges that we have here are things that we've seen in the wild. So if there's any scenario that we discover, or hopefully you have seen something interesting as potential contributors, you could flag it and say, okay, I've seen this interesting thing, and maybe it's a nice idea to make a challenge out of it. You're welcome to do something for that yourself, of course, but you're also welcome, very welcome, to just post it as a potential challenge in an issue in our GitHub. Another thing we're working on is like a multi-user CTF or CTFD support, various UI improvements. We want to have WrongSecrets additionally available as a secret detection testbed, so that various secret detection tools can use it as a sort of benchmark of how well they are at detecting things, or and how good they are at not detecting things that are false positives. And there's much more. For that, please check out our GitHub at commune/WrongSecrets/issues as well. So, having said that, back to you, Jeroen.
All right, sorry, that was technically stuff not helping out. Thank you so much, Ben. Really awesome demo. So now you might ask yourself, okay, there's just tons of ways of how not to do it. So how should we do it? Well, like Ben already mentioned, use WrongSecrets as a secret detection benchmark to find out if there's anything inside that you're not detecting yet in your pipelines. And of course, make sure you also prepare for having the detector actually run as a pre-commit hook instead of just in your pipeline, because hey, you rather want to find out whether something is violating before it hits Git and a lot of other places. So there's a bunch of resources we packed in that in our application, which you can visit, like a blog about secrets management, references to OpenSAM, which is also being presented this conference as well. An awesome talk you should check out. And then, of course, the secret detection topic at GitHub, where you can find a lot of tools, other examples, and other resources you might want to jump into to find out and to learn about secrets management. Then there's the OWASP secrets management cheat sheet that is really recommended to have a read through. Thank you so much, Germanico, for governing that. And then there's the OpenSecEU project, where our project integrated with. That the moment that you go over there, you basically find out all about secrets management in different standards, like the ASVS and other things. So anything OWASP related and other standards as well. By the way, this Friday, there will be an awesome presentation by Robin Spiros about OpenSecEU. And if you're really done with scrolling through hundreds of resources and to Google your ass off every day, you should watch it and see how you can contribute to it, because I think it's an awesome growth towards a better standard to interact with each other. All right. So having that said, the very next question would then be, I suppose, yeah, what can we take away from this? So if you're watching right now or watching this afterwards, this recording, what would be the takeaways from our project in general? And of course, still, try it out, give it a test and learn from it. But let's have a look at the takeaways anyway. First of all, never hard code anywhere. That means anywhere in your configuration, whether it's the metadata of a binary or it's something else, anything really, or in your cloud configuration or in your CI/CD pipeline in a way that you can't really rotate it. Anywhere where it can be at, make sure it's not just hard coded and easily detected. And whether you're an advanced technology user or not, make sure you don't trust the defaults, because many of the platforms that we're using today to create software, to integrate it with our pipelines and to basically deploy it to production, have a set of defaults that are mostly tailored at making sure you can start deploying ASAP, so that you have a few lines of code and you magically have an application that can do stuff. Of course, it's not magic. It's depending on a lot of configuration defaults. And those defaults might actually hamper you if it comes to secrets management. Rotate secrets often, and if you can, use ephemeral secrets, where the secret generation and deletion basically shows an intent to use a certain service, but that the secret will only be there for as long as you have basically used that service for a given request. Reduce the blast radius of your secret. So if a secret is somewhere somewhat hard-coded, or if a secret is easily detectable within your infrastructure or somewhere else, make sure that the secret is not an almighty password to your complete cloud environment and anything else you possibly could attend to. Make sure that that given secret is then only allowing the service consuming it to do exactly what it needs, no extra rights or whatsoever. And make sure you reduce exposure. You don't have to. So the easy thing everybody would think of is, okay, let's make sure all of our, company repositories aren't public. But maybe we should go a few steps further and thinking of, hey, do really everybody in the organization need to have access to all the assets within the organization, or can we tailor it down a little bit? Similarly, should we have maybe policies in our secrets management solution to make sure that some people can access some of the secrets they require, but in most cases, possibly nobody needs access and it's just a computer thing. You only need to see the metadata of a secret. And have logging and alerting in place. Not like the guy from the little Disney movie, but make sure you really can tell when a secret is being accessed. And more importantly, make sure you're able to tell from the resource that is basically used as the place where you authenticate to with the secret, or the place that will basically generate materials with the secret, that that really shows logging and alerting to see like, hey, where is the secret's consumer coming from? Is that from the place it's supposed to be, or is it somewhere completely different? Having that said, we can really use your help. So if you want to have a drive of our project, promote it if you can. Give feedback whether through OWASP Slack or Project WrongSecrets, and try to improve the project with PRs if you feel like, hey, this is something I can do. I would love to contribute a little bit. And of course, we'll list you as one of our contributors then and promote you in any of our sessions. And that sort of concludes our session. A little bit earlier than expected, so we still have a little bit of time left. Are there any questions?
I think there are no questions so far from the audience. And it was really amazing and wonderful session from you guys, because we have covered all the aspects of from the attacker's point of view and to the defender's side, how to find the secrets and how to secure the secrets to reduce the attack surface. And the major key takeaways from this session is like we should not store the secrets in a hard-coded way to reduce the attack surface, and always keep logging and alerting in place. Very insightful and very great session. Thank you so much again. Yeah, I do have some questions. So what is your favorite challenge of the project and why?
You want to start, Jeroen?
Yeah, sure. So my favorite challenge is, let me share my screen on that one. Secrets is, I think, is 14. So 14 is special to me because when I try to explain our project to a friend of mine who's a driving instructor, so it has nothing to do with IT, he was like, hey, isn't this the same as my colleague who just has 1234 as his password to his password manager and then has all these awesome passwords inside, but it's just 1234. And I felt like, that's stupid. Why would he do that? And we figured, that is awesome. That needs to be a challenge. And this challenge basically shows that secrets management is not just some corporate infosec thing or whatever, or a unicorn, let's do this right type of thing, but it's in our daily lives, in every person that needs to, secure access to whatever services he or she is using. You end up having to protect your secrets. So this is, to me, is one of the most awesome challenges because it has a beautiful story behind it.
Thank you for answering the question. So the next question from my end is it is awesome to hear that you're running a multi-cloud application, but what was your experience with building this application for multiple environments?
Right. Yeah. I having built all three of the cloud environments, or well, three of the major public clouds, I should say. It's quite painful to do this, even though we were using Kubernetes, and theoretically that's something that's quite portable, right? You go from one to the other, but there are always implementation details associated with a specific cloud, and especially learning Azure, for example, and how that interacts with our environment was quite a pain. Not even going into the updates and say there's some lifecycle management update, you have to upgrade a major Kubernetes version, and then that's different per cloud as well. So there are quite some things that are painful in maintaining three separate clouds, and I think it's really good to keep a bit of focus if you want to do things well before you go multi-cloud. And there's a lot, actually, because of this, there are some challenges in there specific to some of the clouds that are pitfalls. And if you want to do things in a generic way, like put things in Terraform and put things in Terraform state, for example, you might end up with a secret in Terraform state. And that's also one of the things that we then highlighted as a challenge, so that you can learn from that.
Okay, thanks for answering this question. One more question from the audience. Is it live project? Could we expect new challenges to pop up in the future?
So I'll take this one. So yes, it's a very live project. We have releases almost every 2 weeks. At least that's what we attend to, whether it's maintenance releases, because GitHub is telling us that our resources are outdated again. And to make sure you can use this, we are updating it on a regular basis. We this morning just announced the upcoming of the first binary search challenges, and I don't mean binary search tree like algorithmic fun stuff, but reverse engineer binaries to find the secrets inside, which will start with releasing a C-based challenge, then C++, Golang, Rust, and maybe even Swift. So we can virtually show it doesn't matter which language you use or how you go to machine code. You'll end up in trouble basically. So that's one list. Similarly, there is a few challenges being worked on by a few volunteers already, which are assigned issues, and we have started some of the preparations for CTFD, which is going relatively slow because there's a lot of integration. We need to make sure that it will work properly. And the testbed is continuously extending, and we already hooked up with one of the organizations that publicly said, hey, that's GitGuardian, and GitGuardian, if you're watching this, thank you so much for your support and shouted in your blog. And we basically said we are becoming OWASP member because of this and a few other things. We are in touch with them to make sure that we add more and more secrets, and we hope that other security or secrets vendors will follow to test their stuff at the test bed, and at the same time we're extending it continuously. So not just challenges, but also secrets hidden in one branch to see if you can basically find them.
Yep, awesome to hear that. And the last question, the project shows mostly what is not a good idea in terms of handling secrets. Can you share a few good ideas as well for the same?
Sure. There's a few things. So of course there were the takeaways, right? Let's quickly dive into those so that we can easily still see them. These are the basic takeaways, as in never hard code if you don't have to. Don't trust defaults of the platforms. Make sure you rotate or use ephemeral secrets. And once you start thinking about rotation ephemeral secrets, you automatically end up with one of the more major secret management platforms that are designed to do this well, which can be any of the known Vault projects, basically. Of course, reducing the blast radius of a secret, which means actually not specifically handle secrets management, but really reconsider your identity and access management strategy. So not one account to rule them all, but multiple accounts for different reasons. And good luck with managing those. And of course, the logging and alerting is something that is often very important. What we often see in the wild is that teams often say like, hey, we're never hacked, or we sure our secrets are secure, but there's no log showing when a secret has been used for authentication, for instance, or when some resource that can only be accessed after the secrets is being used, that the access to that given resource is being logged. So make sure you get your logging and alerting in place, not just about from your secrets management tool, but also on those ends where we basically are waiting for the secrets to land in order to be able to do actionable items. So in that sense, yeah, that can be very valuable. And the other thing really is the resources we showed earlier, and those resources still need to be extended a bit. And that will be, let me see if I can quickly pop that up. that will be basically going over these resources, where the OpenCRE link can be really recommended, because then you get tons of resources from the ASVS and other things in terms of actionable items that can really help you, as well as a secret management cheat sheet that more verbally tries to explain what you should do or shouldn't do in situations with the CI/CD and stuff like that.
I'm definitely gonna have a look for the resources. And thanks for the amazing session and the wonderful session. I really appreciate the session. And yeah, so I think we are over. And that's okay. Bye-bye.
Thanks a lot.
Thank you so
Thank you
much.
so much. Bye-bye.